binomial distribution. Before going to discuss about the binomial distribution, now we are discussing about what is a random experiment. Okay. Random experiment. What is a random experiment? An experiment in which the outcome of an experiment cannot be determined. Okay, for example, if you are tossing a coin, then the outcome may be head or tail. Okay, then example, tossing a coin, the outcomes are tossing a coin, the outcomes are head or tail. Okay, the getting head or tail is the outcomes. Then this is a random experiment, example for the random experiment. And one more the example is tossing a die, rolling a die. Consider the case of rolling a die. Okay, then what happened? There are 6 outcomes, 1 to 6. The outcomes are 1 to 6. Rolling a die, we will get 1, 2, up to 6. These are the outcomes. Okay, this type of experiment we will say that random experiment. And consider the same experiment. If you are saying that you are tossing a coin, then you want to get the head. Okay, this is your objective. You want to get the head. Okay, your objective is to get head. But actually, you are checking the outcome. It's found that the coin is tailed. What happened? What happened to this? Then you failed in the experiment. Okay, then the outcomes can be said in the term of success and failure. Okay, there are 2 types of outcomes. These outcomes are successful outcomes are there and failure outcomes are there. Okay, then in binomial distribution as a whole, the term itself by means 2 outcomes. One is successful outcome and second one is failure. Okay, then in binomial terms we are writing that for the probability value for showing the probability of success is P. P stands for probability of success, and Q stands for probability of failure. Consider the same example, tossing a coin. Okay, you are tossing a coin and you want to get the head as your outcome. Okay, then the expected outcomes are head and tail. These are the expected outcome. And you are writing the probability value. The probability of getting head, head is equal to, here 2 outcomes are there, then in denominator 2 is given and only 1 head is there, then you are writing 1. Okay, then the probability of getting head is a success here, then you are written as 1 by 2. And likewise we will get the value of Q, that is probability of failure will be treated as Q, then the value will be 1 minus P. 1 minus P is equal to 1 minus 1 by 2, that is equal to 1 by 2. Okay, these are the basic foundation for understanding the binomial distribution. Coming to one more, I am coming to here, the binomial, the term itself by means success is there and failure is there. Then the probability of success is given by notation P and the probability of failure will be given as Q. Okay, then the probability of success and the probability of failure will be in a function form that we will call as binomial distribution. Okay, then the PDF for the PDF, that is probability density function. It is denoted by PDF. Then the function is function in the form of x, f of x. You are writing that NCX, P raised to x, Q raised to n minus x. Okay, this is the fundamental PDF of binomial distribution. What is that? NCX into P raised to x into Q raised to n minus x. Here n stand for number of events or number of trials. How many number you are doing this trial? Okay, number of trials is denoted by n, and here x stands for the successful outcomes. Number of successful outcome will be treated as x. Number of successful outcome. Okay, this is treated by x. Then here P, we already discussed probability of success. Then coming to Q, that is probability of failure. Then this term, combination term, we know the combination NCX. NCX is equal to n factorial divided by n minus x factorial into x factorial. This is the basic combination. Then the combination is here and every notations are here. And the value of x running from 0 up to etc. n. These are the values given for the n. Okay. Consider the example which is written here. 4 coins are tossed simultaneously. What is the probability of getting 2 heads? Okay. What is the probability of getting 2 heads? This is the question. Then here we can see that 4 coins. Then number of coins, that is number of trials or experiments are 4 number of trials. Then n is equal to 4. And here also 2 heads. That is also x. X stands for favorable. You want to get x, head. Then the x is 2. 2 heads. Then you want to get 2 heads. That is x is denoted by 2. And we will be putting in the form. We know the P of getting x. Probability of getting head is equal to head is written here h. Then probability of getting head is equal to 1 by 2. And we know the Q is equal to 1 minus 1 by 2. That is also 1 by 2. Then every terms are there. Then we are putting it to PDF, probability density function. The answer will be 4C2. Then P stands for 1 by 2. 1 by 2 the whole raised to x, that is 2. Then what is the next term? That is also 1 by 2. Then 4 minus 2. Okay, we fitted in the distribution form. Then the answer will be 4C2, that is 4 factorial divided by 4 minus 2 factorial into 2 factorial into 1 by 2 square into 1 by 2 square. Okay, then the answer will be 4 into 3 into 2 factorial divided by 2 factorial into 2 factorial. Okay, you can cross this 2 factorial with the 2 factorial and this 2 with the 4, then 2. Okay, then the value will be 6 and remaining will be 1 by 4 and 1 by 4. Okay, then the answer is 6 into 1 by 4 into 4. Okay, then you can cross this. This is 2, this is 3, then the value will be 3 by 8. Then the probability, the chance of getting 2 heads in this trial is 3 by 8. Then our objective is to understand how to fit a distribution. Then coming to fitting problem, 8 coins were tossed together 256 times. Find the expected frequencies. This is the question. Here we can get the number of coins, 8 coins. Okay, then n is equal to number of coins, 8 coins. Tossed, how many times it is tossing? 256. The actual frequency is equal to 256 times. Okay, then our binomial distribution will be, the distribution is function of x, f of x is equal to ncx into p raised to x into q raised to n minus x. This is our binomial distribution. Here the n is equal to 8 times. Okay, then the actual frequency is 256 times and the probability of getting head, getting head is equal to p, that is equal to 1 by 2. We already did this problem. And the probability of getting failure, that is q, that is 1 minus p equal to 1 minus 1 by 2. Then p is 1 by 2 and q is also 1 by 2. Then we are putting to this equation and framing a model. That binomial distribution model will be for frequency x is equal to, the n stands for 8, c, then x, we don't know what is the real value of x, and p is 1 by 2, then the 1 by 2 whole raised to x, and q raised to 8 minus n. This is the model. Okay, then here we know the values up to n. We can have the x values of x. Then the x, we are putting the value from 0, then 1, then 2, etc. up to this maximum number is 8 times. Then the up to 8 you can have the value of x. Then the function will be f of x is equal to 0. Then the f of x is equal to 0, then 8c0 1 by 2 the whole raised to 0, then 1 by 2 the whole raised to 8 minus 0. Then what is the answer? Then 8c0, 8 factorial divided by 8 minus 0 factorial into 0 factorial. 1 by 2 the whole raised to 0, the value will be 1. Then 1 by 2 the whole raised to 8. Okay. Then we will get the value as 1 by 256 as our value. That is a probability value. For the first case, we got the value 1 by 256. Likewise, we can apply the value f of x is equal to 1, then f of x is equal to 2, then f of x is equal to 3, etc. up to, we can have the value up to 8. Then we need to calculate the expected frequency. This is a question. What is the expected frequency? The expected, here the actual frequency is there, 256 times the actual frequency. Then you have to multiply with the probability value, that is f of x value, with the actual frequency to get the expected frequency. Okay. Then one more time I am telling, then you have to take the probability value with the actual frequency to get the expected frequency. Then the equation will be, this is the equation, you have to take the actual frequency into the probability value is equal to your expected frequency. Okay. Then here considering the first case, our answer is 1 by 256. Then 1 by 256 as the probability value into actual frequency is how much? 256. Then you are multiplying with the 256. Then our expected frequency is 1. Likewise, you have to do the problem up to 8 values. Then you are getting the expected frequency. This is all about the binomial distribution. In this class, we discuss about what is a binomial distribution, what is a random experiment, then how the outcomes can be, what is success, what is a failure, and what is the probability density function of a binomial distribution. The probability density function will be ncx into p raised to x into q raised to n minus x, and how to fit a distribution. Okay. The table will be the answer for the fitting question.